Assalamualaikum warahmatullahi wabarakatuh. Today we will learn the linear equation. First of all, let's see how to identify the linear equation. Okay, if you still remember the first part of this chapter, we have been introduced to the independent variable and dependent variable. Okay, so how to identify the linear equation? First, there are two conditions that you should remember, where the first one is the dependent variable and its derivative must have degree of 1. Okay, degree of 1, meaning the power. So you can see that in the equation that we have here, this is the power of 1, this is also the power of 1. Okay, so that's what it meant by dependent variable and its derivative must have the degree of 1. The second condition is that the independent variable must be not independent variable. The coefficient, okay, must be in the form of independent variable. All right, so if y is the dependent variable, in this case we have x is the independent variable, so that's why you can see the coefficient that we have here is in the form of independent variable function. So that is how we identify the linear equation. Now, the first step that we should do to solve the linear equation is to divide the whole equation with the coefficient for dy dx here. Okay, so we divide everything with ax function, and that will give us 1 here, right? This will become 1. And then we have b over a, that will be given by p, and c over a, which is given by q. Next, we identify the p and the q function from the new differential equation function that we have. Okay, so the p is given by this and the q is given by this one. Next, how do we solve the linear equation? Once we determine the p function and q function, okay, we take the integrating factor. Okay, the integrating factor is given by this formula, exponent integration of px dx. And then we write the equation in the form of this. Okay, in the form of this. So what do we do with the integrating factor is actually we are going to multiply the integrating factor with the differential equation that we have here. And the simplification of this will be given like this. Okay, can be written as this. Next, we want to remove the dx here, then bring it to the right hand side. That will leave us with mu xy, and since we are looking for the y, we have to divide the whole integral here with 1 over mu, and this is the solution that we should get. Okay, now let's go to the first example for this topic. Okay, so when we look at the differential equation here, okay, you can see here we have the differential equation, and automatically we know that the coefficient for dy dx is already 1. Therefore, we can say the function that we have here is the px, okay, and this is the qx. Okay, so determine px and qx, that is the first step. Then we can write down px equal to and qx equal to this. So once we determine the p and q, we can find the integrating factor by having mu x. Mu is a function of x. By writing the integration, the exponential of this p is 1 plus x over x dx. That will give us the exponent integration of 1 over x plus 1 dx. How do I get that? I just divide everything with x like this. Okay, this is what I get. Next, we have exponent integration of this. We got the ln, okay, ln x plus x. Okay. And it's very important that you know how to simplify the exponent here. In this case, the simplification is given as this. Okay, you can check the index topic. The summation of the power for exponent is actually the multiplication, okay, of the exponent. And then we can see that we have the exponent and the ln, okay, ln is the inverse to the exponent here. So this one can be cancelled out, and what we will have for the mu is only x, dx like this. Now, write down the equation. We have the mu already, okay? So the equation is supposed to be like this. We have y prime, plus 1 plus x over x, y equal to ex over what just now, qx. Okay, so this is the original equation, and when we multiply the whole equation with the mu factor, okay, integrating factor, then we will have x ex y prime plus x ex 1 plus x equal to x ex over x. So basically what we have on the right hand side is actually, this is already mu q, like that. Okay, and this one is actually can be written as the differentiation, okay, of mu x y, like that. Okay, this one we can simplify, cancel and cancel here, and we have here e to x. Okay, I write it here. Like this. Okay, so this is actually, you can skip this part lah. I'm just showing, okay, where we are going to use the mu actually. Okay, but if you already understand, you can just skip. Once you get the mu, you can just skip to the good part here. Okay, now we have to bring the dx to the right hand side. That will give us the integration of dx here, which is given by e to x over 2 plus c. Okay, that one is mu x, sorry, mu is x ex. That is our mu. And to find y, we have to multiply the whole right side equation here with, okay, we divide with 1 over this, right? So we can cancel this one and this one here. That will give us y equal to ex over 2x plus c over x, like that. Okay, so you can see the final answer is given like this. Oh, sorry, we cannot cancel with this one. This, of course, we cannot cancel. We will have e to x here, and if we multiply, sorry, we will have e to x over 2x ex plus c over x ex. So now we can cancel this one. Okay, so that's why the final answer we can write down in this form. Okay.